Hello students, in this lecture we are going to discuss question number 12 and 13 from exercise 5.5 of class 12th mathematics. So these are the problems. Now there is some similarity in these two problems. In this we have x raised to power y plus y raised to power x equals to 1. In this we have y raised to power x equals to x raised to power y. So these are similar, but the method is different. We will use different method. In this, directly we can use logarithm on both the sides. But in this question, we cannot use logarithm on both the sides directly. So what should we do in this question number 12? So we will solve this as, first of all we will assume these two functions as u and v. So let u equals to x raised to power y and v equals to y raised to power x. Then this given function is u plus v equals to 1. Now differentiating both sides with respect to x, then this is d by dx of u plus v and d by dx of 1. So this is du by dx plus dv by dx, and on right hand side we have 0. It means we will find the value of du by dx and dv by dx separately and put in this equation. But here we can directly use logarithm. So first of all we will find du by dx. So u is x raised to power y. Now in this x is a function and its exponent is again a function. So we will use logarithm. So by using logarithm we can write taking log on both sides. So we will get log u equals to log x raised to power y. Now this can be written as log u. On right hand side we will use the property of logarithm. So this can be written as y log x. Now we will differentiate both the sides. So differentiating both sides with respect to x. So this is 1 by u du by dx as we have done in previous questions. That is question number 6, question number 9. Now these two are in product, so we will use product rule. So first function as it is. Now derivative of log x is 1 by x plus this second function as it is. Now derivative of first function, that is y, is dy by dx. So this is what? 1 upon u du by dx. So when we transfer this u on the right hand side, then we have du by dx equals to u. In product we have y by x plus log x and dy by dx. Now we will put the value of u, and u is x raised to power y. So finally du by dx is x raised to power y, y by x plus log x and dy by dx. Now when we multiply both the terms by this x raised to power y, then we will get, when we multiply these two, then look, this is x raised to power y. Here we have x raised to power 1. So base are same. So powers are subtracted. So we can write this as x raised to power y minus 1 in product y plus. When we multiply this by the second term, we will get x raised to power y log x dy by dx. So this is the value of du by dx. Suppose this is first, this is second. Now we will find the value of dv by dx. So v is now taking log on both sides, then we will get log v equals to log y raised to power x. Now by the same method that we have used for u, this log v is as it is, and this can be written as x log y. Now differentiating both sides with respect to x, then we will get this is 1 by v dv by dx. On right hand side we will use product rule. So first function is as it is, and differentiation of log y is 1 by y, and this is not x. So we will write the product of this in the product plus second function as it is, and differentiation of x is 1. So finally when we write this v on the right hand side, then we will get dv by dx equals to v, and it is x by y dy by dx plus log y. Now we will put the value of v, and what is the value of v? Y raised to power x. So finally dv by dx equals to y raised to power x in bracket x by y dy by dx plus log y. When we multiply this y by x with both the terms, then we will get for this first term y raised to power x, and here y raised to power 1. These two are having same base and they are in division, so the powers are subtracted. So we can write y raised to power x minus 1 in product we have x and dy by dx plus, when we multiply this with the other term, then we will get y raised to power x and log y. So this is third. Now we will put the values of du by dx and dv by dx from second and third in first. So by using second and third in first, so we can write this equals to 0. So du by dx is from first, this is the value. So we can write x raised to power y minus 1 into y plus x raised to power y log x and dy by dx plus the value of dv by dx is from third, this is y raised to power x minus 1 into x and dy by dx plus y raised to power x and log y equals to 0. Now these are 4 terms. Out of these 4 terms, 2 are having dy by dx. So we will take common from these 2 terms and transfer the rest of the terms on the right hand side. So we will get dy by dx in bracket x raised to power y and log x plus y raised to power x minus 1 x. On right hand side, when we transfer these two terms, then the sign will change. So minus in bracket we can write x raised to power y minus 1 into y plus y raised to power x and log y. So when we find dy by dx, then transfer these terms on the right hand side. So this will become in division. So finally we will get the value of dy by dx as minus, this term is as it is. So this is x raised to power y minus 1 into y plus y raised to power x and log y. In denominator, we will have this term. In denominator, this is x raised to power y log x plus y raised to power x minus 1 into x. So this is the derivative of this given function with respect to x. So we can write this here. This is dy by dx and this is minus, in numerator we have x raised to power y minus 1 into y plus y raised to power x and this is log y. In denominator we have x raised to power y log x plus y raised to power x minus 1 into x. So this is dy by dx for question number 12. Now come to question number 13. This is different from question number 12. In question number 12, we cannot use directly the logarithm. But in this, we can directly use logarithm. So taking log on both sides, then we will get log y raised to power x equals to log x raised to power. This implies that by the property of logarithm, this can be written as x log y and the right hand side can be written as y log x. Now differentiating both sides with respect to x. So on both the sides the functions are in product form. So in left hand side as well as in right hand side we will use product rule. So on left hand side these two functions are in product. So we can write d by dx of x log y. So these two are in product. On right hand side d by dx of y log x. These two are also in product. So on both the sides we will differentiate the functions by using product rule. So on left hand side this first function is as it is and the derivative of log y is 1 by y, and since this is not x, so we will write the derivative of this y in the product plus second function log y is as it is and the differentiation of x is 1. On the right hand side this y is as it is and the derivative of log x is 1 by x plus the second function log x is as it is and the derivative of y is dy by dx. Now we will collect the like terms. The terms containing dy by dx on the left side and the other terms on the right hand side. So this is x by y dy by dx, and we will transfer this term on the left hand side. Then we have minus log x dy by dx. We have y by x on the right hand side, and we will transfer this term on the right hand side, so we will get minus log y. Now dy by dx is common, so in the bracket we have x by y minus log x. On right hand side we have y minus x log y. So in the same way, when we simplify the left hand side, we will get dy by dx. This is x minus y log x by y equals to, this is y minus x log y by x. Now the value of dy by dx is y minus x log y by x, and when we transfer this on the right hand side, then this becomes y by x minus y log x. Now we have y by x, so dy by dx is y by x in numerator. This is y minus x log y. In denominator we have x minus y log x. So this is the derivative of the given function. So in this way, according to the situation, we will use the logarithm and solve the problem.